In 1981, somebody changed a small detail on a construction drawing for a hotel in Kansas City. It was not a redesign. It was a change to how a set of steel rods was arranged, the kind of adjustment that gets made on building sites constantly because something is awkward to manufacture. Nobody recalculated what it did to the loads. What it did was double the force on one connection, and 114 people died at a dance. Every disaster in this video has a famous technical cause: a rod, a rubber seal, a reactor design. And in every single one, somebody had already worked out that there was a problem and had said so. So that's the actual story, not what broke. Who was told? The Hyatt Regency in Kansas City opened in 1980, and the centerpiece was the atrium. A huge open space, with walkways suspended above it on steel rods, so that people could cross the building in mid-air. On the 17th of July, 1981, there was a tea dance in that atrium. Around 1,600 people came. Some were dancing on the floor, and a lot of them were standing on the walkways to watch. So, here's the engineering, and it's simple enough that anyone can follow it, which is part of why this case is taught everywhere. The original design had long steel rods hanging from the roof. Each rod passed through the fourth-floor walkway and continued down to the second-floor walkway below it. Each walkway hung from the rod independently. The nut under the fourth floor held up the fourth floor. The nut at the bottom held up the second floor. The problem with that design is practical. It means threading a nut up an enormous length of rod and damaging the threads on the way. The fabricator raised it. So the detail was changed. Instead of one continuous rod, there were now two shorter ones. An upper rod from the roof to the fourth-floor walkway, and a separate rod hanging from the fourth-floor walkway down to the second, which looks almost identical on paper. And it isn't. Because now the second-floor walkway does not hang from the roof. It hangs from the fourth-floor walkway, so the connection at the fourth floor is carrying its own walkway and everything below it. Twice the load it was designed for. Nobody did that calculation. The change was made and approved as a fabrication detail. And the original design had already been below what the building code required. The change took a connection that was under strength and roughly halved it again. That evening, under the weight of the people standing on it, the fourth-floor connection failed, and both walkways came down into the atrium. 114 people died. More than 200 were injured. At the time, it was the deadliest structural collapse in American history. The engineers of record lost their licenses, and the case became a permanent fixture in engineering education. Not because the mechanics are complicated, but because of how ordinary the failure was: a practical objection, a sensible-looking fix, and no one asking the one question. The space shuttle's booster rockets were built in segments and stacked, and the joints between segments were sealed with rubber O-rings. Their job was to expand instantly under pressure and close the gap. Rubber gets stiff when it's cold. A cold O-ring seals more slowly. Engineers at the company that built the boosters had been worried about those joints for years. One of them, Roger Boisjoli, had written a memo the previous summer warning that a failure in that seal could destroy the vehicle and everyone aboard. The night before the launch, Florida was unusually cold. Ice formed on the launch tower overnight. The forecast temperature at launch was far below anything the shuttle had ever flown in. So the engineers asked for a teleconference and recommended not launching. And what happened in that call is the reason this act exists. They presented what they had. The data was messy. It was not a clean curve, and they could not point to a single chart that proved the danger at a specific temperature. But their engineering judgment was unanimous, and the recommendation was no. And then they were asked to prove that it was unsafe. That reversal is the whole thing. Normally, the burden runs the other way. You must show a thing is safe before you fly it. That night, it flipped, and the engineers were asked to demonstrate certainty about something nobody had data for because nobody had ever launched in that cold. There was a break in the call. Management at the contractor discussed it among themselves. One senior figure was told in a line that has followed the case ever since to take off his engineering hat and put on his management hat. They came back on the line and recommended launching. At least one engineer refused to sign the recommendation. Challenger launched the next morning and was lost 73 seconds later with 7 people aboard. The joint failed almost immediately. There is footage showing smoke escaping from that joint in the first second of flight. The investigation afterwards found exactly what the engineers had said the night before. And it found the other thing too, that the concerns had been raised repeatedly in writing, for years, and had been absorbed into a system that had come to treat previous survival as evidence of safety. In both of those, the warning reached the room. Somebody said it out loud, to the people who could stop it, and was overruled. The next two are worse than that. In the next two, the warning existed, and never got to the people who needed it at all. On April 26, 1986, the crew at Chernobyl were running a safety test. And that's worth sitting with for a second. The test was about safety. It was checking whether, in a power cut, the spinning turbine could generate enough electricity on its own to keep the cooling pumps running for the few seconds before the backup generators came up. It had been attempted before, and hadn't worked. It was rescheduled, delayed by grid demand, and ended up being run in the middle of the night by a shift that had not expected to do it. The reactor was in an unstable state, running at very low power, which that design does not handle well. And here is the part that matters. The reactor had a characteristic that made it unstable at low power, in a way most reactor designs are not. The operators were broadly aware of that. What they were not told was the second thing. The control rods, the things you push in to shut the reaction down, had graphite on their tips. And graphite does the opposite of what a control rod is for. It increases the reaction. The idea was efficiency during normal operation, and in normal conditions it was fine. But it meant that in the first moments after the emergency shutdown button was pressed, as the rods began to enter, the graphite went in first, and the reaction briefly got faster before it got slower. In an unstable low-power state, that brief increase was catastrophic. Now, this was not unknown. The effect had been identified years earlier, after an incident at another plant using the same design. It had been documented and reported, and it had not been passed down to the people operating the reactors. The crew at Chernobyl did not know that the emergency stop could, in certain conditions, make things worse for a moment. At the end of the test, with the reactor behaving badly, the shift leader did the correct thing, according to everything he had been taught. He ordered the emergency shutdown. The information that would have told him not to existed. It had existed for years, it was in a report, and the report had not reached the control room. Go back 3.5 centuries to the simplest version of this. In the 1620s, Sweden was at war and building a navy, and the king, Gustavus Adolphus, ordered a flagship. He wanted it large, he wanted it magnificent, and, as the project went on, he wanted more guns than had originally been planned, on a second gun deck. Adding a second gun deck to a ship already under construction raises the weight high up, to stay upright. A ship like that needs to be wider, or carry much more ballast low down, or both. The Vasa was neither wide enough, nor heavy enough underneath. She was tall, narrow, extraordinarily ornate, and carried the heaviest guns high above the waterline. Shipbuilding at the time had no calculations for this. Stability was judged by experience and by rules of thumb, and the men building her were working from a design the king kept changing while they were building it. But they did test her, and that's the part that makes this act belong in this video. Before she sailed, an admiral ran a stability demonstration at the quay. 30 men ran from one side of the deck to the other and back to see how she rolled. By the third run, she was heeling so badly that he ordered it stopped because he thought she would go over right there in the harbor. Everyone present saw it. It was witnessed and it was discussed, and she sailed anyway, on the 10th of August, 1628, with the crowds out and the flags up, because the king had been asking about her for months and was away at war, and nobody was willing to be the person who told him his flagship would not be sailing. She traveled roughly a kilometer. A gust caught her. She heeled. Water came in through the open gun ports, and she went down in full view of the city. Around 30 people died. At the inquiry afterwards, the questioning went round in circles, because everybody involved could correctly say they had built exactly what they were told to build. Nobody was punished. There was no one to punish, which was the finding, and also the problem. Every one of these has a technical cause you can point at. A connection, a seal, a control rod, a center of gravity, and every one of them also had a person who knew, a fabricator who raised a practical problem and a change nobody checked. Engineers who said don't launch and were asked to prove it instead. A report about a control rod, written years earlier, that never traveled to a control room. And an admiral who watched a ship nearly capsize at a quay and could not stop it leaving. The information existed in all four. That is not the failure. The failure is that in every case, the information had to move upward, from someone with less authority to someone with more. And upward is the direction organizations are worst at moving things. A warning going down a hierarchy is an instruction. A warning going up is an inconvenience. That's the whole pattern, and it's the reason the Kansas City case is still taught to first-year engineering students, and the reason the shuttle report spent as much time on meetings as on hardware. Nothing in these four broke because somebody was stupid, they broke because somebody was junior. If you want more of these, the strange, hard, mostly forgotten corners of history, subscribing is how you get them. It genuinely helps, and it's free. And if you want the same pattern with armies instead of engineers, 4 disasters caused by certainty rather than cowardice, that one's on the screen now.